Alright, so everything that we've been doing so far has been in 2D, right? So we have a planar system, let's say in the XY plane or something, right? 2D planar, the same thing, right? But here's the case, looking at this particular example here, or this particular problem here, everything is in 3D, right? So meaning that we are doing a 3D something, right? 3D spatial, or at times we can, that's how I've made it this way, forces in the space, right? What is trying to say here that we haven't 3 coordinates, right? So then whenever you have a problem like this, as we've been discussing, it's much more, it makes sense if you try to establish a convention so that you stick to your convention, so that everything is consistent. So let's say now our focus of interest here is this thing, right, which is the tar. This is the tar, right? This is the tar. So let's see. Now I'm trying to introduce the coordinate system that we'll be using. At times, because the 3D system, they might give it to you, but if they don't, try and introduce yours. It won't change anything that much. Just have to be consistent with whatever that you are doing. Okay, so let's see. So let's make it this way. This is our x, this one is our z in the direction of the tar, and then here is our y, right? Yeah, so we've established our conversion. Then again, it's saying that the y, right, is anchored by means of a bolt, meaning that in general terms, this is something that must consider. You don't have to think like write all these, but the moment you miss something, everything will be messy. Okay, so that's what we do. If this wire is not here, this the tar might topple and then fall on the other side. That's why this wire is holding. So somehow there's tension in the wire. So if there's tension in the wire, this will happen. It means that the wire is being stretched, right? This is extending the force on it. So it's in actual sense actually pulling the bolt, which is here, right? So meaning that there's a force acting in this direction. Are we okay? So this force here is our force of interest. That so the question is saying that we should find the x component, y, and the z, right? So that's what we are doing. But all that we've done in 3D so far, it's much more logical that you find one along one coordinate system and then resolve along a plane. We'll talk about that one later. So now let's talk about the z. It's much more clear that this force F is here, right? If this force F is here, we know that there's the height, which here is 8 meters, right? And then we don't know the height of this F, but we just know there's a force there. But then looking at it, because we are moving from here to here to be something like this, right? And if it is that way, let's see, this will happen. Something like this, right? To find this downside here, this is what we do. We know this down, which is 40 meters here, so let's do that. 40 meters, right? And then we know this side, which is here, to be 30 meters, right? So this is the force. Now I'm trying to find this FZ, which is here, right? To find the FZ, what do we need? The angle that this F is actually making with this Z is this angle, right? So theta Z, right? So this is what we do. The 90 degrees is here, so this is what we do. We're trying to find here which is the adjacent side. So to find FZ, let's use cos, right? But then again, we'll consider the direction as we've been doing so far. This FZ here, right? This or the axis here, as in the Z here, is in the same direction as this F here, right? So positive. Now the magnitude of the force, which is 2500 newtons, right? 2500, right? And then we need cos, adjacent hypotenuse. We have the distance here. We need the distance here, right, to get that component of the force. So this is what we do. We have this and this, so we can get that side is 50. We end up getting 50 for this particular side. So let's see. Let's verify. Okay, so square root of 30 squared, 40 squared. Alright, so 50 here. There's another way to get for the distance here though, but we'll go about that. We'll talk about that one later. So what do we have for this side? You have to 50, right? So now to get the FZ, that's what we are doing. We need cos, right? So let's see. Cos theta Z. So this is the same as 2500. The cos theta Z here is adjacent. Adjacent is 80. Our hypotenuse is what? We had the 50 here, so we can use to get the distance here, the magnitude here. Let's see. Now we are using 80 and then 50. So it's a 50 squared plus 18 squared, right? So that's giving us what? 94.34, right, meters. Right, so that give us our FZ, straightforward. So let's see, 2500, the direction is positive already, times, what do we get, 280 on what, 94.34, right, so this is what I'm getting, 2119.99 newtons. Right, so this is what's happening. Now that we have this FZ, let's go back to the diagram. Now that we have this FZ, the rest of the components of the force will lie here. Right, let me clean this and draw this wall. So for this particular, we know this FZ, right, this FZ here, this FZ here is what we know to be here, right? And now we know this down here to be the magnitude of having 50 from here, top here, and then here. This is a triangle that we're having here, right? But here's the case that this particular down here is also another force, because we have the FZ here. This will be another force, right? But this particular force lies within the XY plane per what we did, right? You see, when we drew our plane, that's what we did. We have the Z to be here, we have the X to be here, and this side is the Y, right? So this one lies within the XY plane, right? So in order to get Fx and then Fy, you have to resolve this particular force to get the X component and the Y component. And then to get this particular force, which is this side, we get it using this triangle. So let's say, because that force in the XY plane, just do it this way, Fxy, right? We know that force is within the XY plane. So to get that one, we just use sine, because per this particular triangle here, just opposite, right? So this is what we do. Then again, we look at the directions, right? Looking at this one, the original force lies in this direction, right? Let's clean it and see what's happening. So the original, this force here that we are resolving lies in this direction, right? And then you can have it is, this is the component of it in this direction. So let's see if we get it along the XY plane to be something. Okay, let's see. This is this way, this is this way, so it's this way, right? So it's actually in the same line, so the direction is still positive, right? So because this is a resultant, right? This is a resultant, so this should be here and this should be here, so this gets that our resultant, right? So it's actually positive. This one here is in this direction, right? So the other one is just a sine, right? We need a full force, which is 2500, and then we need sine theta z, not just any time, not just anything, right? So let's see. Okay. Theta and then z, right, which is the same as this. We have 2500. Let me write this wall. 2500, and then sine theta z, opposite of our hypotenuse, right? We have the distance already. This is the opposite, which is 50, right? And the hypotenuse is what, 94.34, right? Yeah, that gives us our Fxy. When we get that one, we are not done. It's what will help us to get the Fx and then the Fy, right? So it's 2500 times 50 on 94.34, right? So this is what we are getting. 25 is actually times, so and I'm getting 1324.99 newtons, right? So this is what I get for the Fx. Why? Because that's the force that lies within the XY plane, right? A plane something like this, where here is the X and then here is the Y, right? So whatever we're having here is like a resultant. So we can resolve to get the Y component, X component. That's what we're doing right now. So we have the full force. Now our aim is to find the Fx, right? Because that's what that's the main focus of what we are doing, right? In order to get this Fx, now let's look at direction. Is very important, because if you miss the direction, you are doing something else, right? We initially, when we started, we did it this way, where we have our X here, Z here, and then here's our Y, right? And now we have the Fxy. We know the Fxy was actually here and the direction was this way, right? So because it's in the opposite direction, the X component here will be negative, right? Now we have it to be negative. Then again, it's a triangle, right? Something like this. where here is the fxy, here this direction is the, what's the name, fx, right? Then meaning that here will be the fy, right? So now we're trying to find the fx. Let's bring it down. Then we find the fy later. So fx, right? We know it's in the opposite direction, right? Per what we have here, so negative, right? And then we have the full force. The full force here, or the resultant, right, is this one, the fxy. So let's just write that one, 1324.99, right? 0.99. Then again, the direction are what we get from the negative and positive. So just put them there, even if it's positive, so that you don't get confused or something. So let's see. See. Okay. So this is a negative. A negative. Right. So this what's the name? There's the angle here, right? This fx here, actually in actual sense, because of what we've done so far, this angle here is not just theta, but it will be something like, let's say, let's bring it here, something like theta x z, because it's the angle that the force will make with the xy plane, right? So let's make it that way. So now trying to get this side, right, which is the adjacent. So let's see, cos is actually cos adjacent, right? So cos theta x y is actually xy, right? So that's what we do. We know negative 1324.99, right? And we need a cos adjacent of hypotenuse. So let's see, per what we have here, or per this particular triangle, this fx here is what we have here, this 40, right? So we just put it there, the adjacent, right? The hypotenuse is which one? The fxy, the distance there, which we found to be what? 50. So we just put it there, right? So this is what we get, this times, and then our fy, this is how our fy will be based on this particular triangle. Again, that's what it will be. Our fy is in this direction, right? And the force that we are having, this particular one, let's go back to the diagram, is having the original force is in this direction. But here's the case, we resolved. So our interest right now as a resultant is this one, right? So this one is in this direction, this one is in this direction. So somehow it will be opposite when we try to resolve, right? So opposite. So let's see, negative, right? Our fy is negative. And then we have the full force, which is 1324.99, right? Per this particular thing here, the fy is opposite to the angle, right? So sine theta what? Xy, right? So this is what we do, minus 1324.99, and the sine opposite of adjacent, the opposite, the fy, where is it? We know from this particular side for it to be 30, right? And then the hypotenuse, we know that one to be 50, so we put that one there. So now let's see what we get for these two. Then again, the negatives are there so that we keep the direction. The moment you miss the direction, everything is messed up. So let's see. Minus 1324.99. Then we have this 40 and 50, right? So this is what we are getting, minus 1059.99 newtons. Now let's see for the y, the same for about 30 here, minus 794.99 newtons, right? So this is all the forces that we're having, right? So now the other side of the question is asking us to find the angle that these forces make with the original force, which is this one, right? So let's see. We are trying to find theta x, theta y, and then theta z, right? Because we find the fx, fy, and fz. So for theta z, because we are trying to find the angle that it makes with the full force itself, we just use cos. We don't think about whether it's adjacent or opposite or whatever, because we're whatever the case, because we are still considering this full force here, let me clean everything so I will see everything well. Because you are considering this full force here, whatever the angle that it will be relative to this one. So just, even if, let's say we made here y, we made here x, right, and we made here this one z, right. So then whatever that we are doing to be just the axis will be just adjacent to the angle, right. So to find the theta x, this is what we do. We know the full force and we know the fx, right. So we just use cos inverse, right. Let's open this up so we can get the answer as well. Cos inverse, and then we have the fx, right. What is it? Minus. Then again, the negative should always come. Everything is messed up. 1059.99, right? All over the full force, which is this one, 2500, right? 2500, right? So let's see. This is what we get. Let's return and then do everything at once. And then theta y. Theta y, right? Cos inverse again, right? And then fy minus 794.99, right? The full force is 2500. The actual force they are trying to resolve. And then we have theta z, right? Cos inverse again. Then fz. What's our fz? 2119.99. Let's see. There it was positive, so we'll just make it that way. 2119.99, right? And then the full force is 2500. Let's see what we get for these guys. I don't know how much I should stress on this, but the signs very important. The moment you switch a negative for a positive, what's it about? Like everything is gone. So let's see. Cos inverse, right? What do we have here? Minus 1059.99, right? You have 2500. So this is what we get. 115. Let me write this one. 115.08 degrees, which is around like 115 degrees, right? Let me write this out. Well, so we see what's happening. When it comes to degrees, generally we just make them full numbers, like whole numbers, right? Yeah. So let's just write whole numbers. 115 degrees, right? And then theta y. Let's see. Minus is there, so let's maintain it. 794.99, right? That's giving us 108.54 degrees. And then theta z, that's positive, right? If like bring it there, so your x becomes easier. So you don't be thinking a lot about this stuff, right? And here we have 32 degrees, right? So here it's like 108. Yes, we are done. Let's see if we are on the right path. Okay, so fx. So looking at how it is, like their y is here, their y is here, their x is here, and then their z is here. Then again, if we did the right, then it's just the labeling that will change, right? So let's see, f of x. What did they get? F of x. Our f of x is in the same direction as theirs, so we got this ours. So we did it this way. Okay, so ours is x here, and then we add the z here, and then we add the y here, right? Let's write it all so we can differentiate. So per what they've done here, this is their x, this is their y, sorry, this is their z, this is their z, and then this is their y in this direction, right? But for what we did, this is what we did. We had, let me use another color so it's much more clearer. Let's see. For what we did, we introduced our y here, right? So which is like negative z. We just see that it's just a matter of science and stuff. We had our x here, the same thing, and then where we have the y for this, ours is z, right? So let's see what happens. Okay. Our f of x which is the same as theirs, should have the same sign, and the same magnitude, right? So let's see f of x. Yeah, so is that the same negative sign and then 1060, right? F of y. F of y should be our f of y. Where's ours? This is our f of y. Should be opposite. Should be the negative sign as the f of z, but should have the same magnitude. So this is the f of z. Let's see. So f of y, 794.99, which is like 795, right? So the same thing. So you see, ours is negative, yes, it's positive. So you see, the same thing. Just a matter of the negative and positive. So the moment you use the particular conversion during the solving, if they don't give you the coordinate system and you use yours, be consistent. Okay, else like everything will change. So here we are negative. That's why I'm making it clear here. Right. Now go to our what's the name? F of z. Where's our f of z? Okay, for our f of z, we have our f of z will be the f of y, the same magnitude, the same direction, right? So let's see. The f of y is where is it? Oh, there's it. This is our f of z, right? So we have 2119.99, which is approximately 2120, right? So you see, our positive is here. We didn't write so positive. So you see the same thing. So we are on the right path. Now let's look at our angles. Okay. So because our theta x here will be the theta x. So let's see, theta x 115, yes, 0.1. I remember there was some we missed it. Our theta y will be the what's the name? Our theta y will be the kind of like theta z, but minus 180, right? So let's see, but it should be the same. Theta y should be the theta z. There's it. This is our theta y, theta z. So we'll check that one later. So now our theta z, where is it? Our z was here. Our z is this side, right? So it should be the same as the theta y. So 32, right? So we had all the forces here, right? And then the theta x we had the right, theta y we had the right. Now our interest is the theta z, right? Which is our theta y. So now let's look at it. Because they introduced their z here and ours is here, if you want to move from this side to this side, it's like anti-clockwise. So you take 180 from it. So we had what's the name? 108.54, right? So let's say it depends, but it's in this way. The difference between them is 118. So should we add or subtract? Okay, ours is here, so we are bringing it here. So we take this one from 180. Let's see. So 180 is just the same thing because we didn't look at the coordinate system that they use. We just did ours straightforward. That's why we are getting a bit different values, but it's the same thing. So let's see. If they give you the coordinate system, fine, just follow it. Right, 108.54. Let me write this one. Right, so let's see what we get for these guys. When it comes to this stuff, if your calculator is close by, you just do it fast. And you have to know the baby. Let's see. This is 72 degrees, right? 72. So you see, 71.5, which is approximately the same thing. So yeah, we're on the right path. They brought this stuff here. I think there's a way to talk about this one. This one is just the same thing, right? But now we've solved everything that we are looking for. Everything that the question was asking us to find, we've done it. Everything here. Alright.